chop up the beetroot, but that's fine, we can show them that as we go. So as Mr. Borde rightly said, we're going to do a follow-on from Mr. Golding's fantastic video about osmosis. Now he showed you exactly how it's done if we were to do it at school with potato chips and the exact required practical. I'm going to show you something slightly different, a different way you can do it, using beetroot. What else could they use, Mr. Borde?
What?
I am moving around so you can see what I'm doing. What else could they use other than beetroot? Oh.
Did you wash it up?
Can you see? Oh, sorry. No, that is the washing up. It's done. Right, so what I've got here is I've chopped up a beetroot, and I hate beetroot, so this is like the best use of beetroot, I think. Just use it in an experiment. And I've chopped it up into 4 equal sized pieces like that. And then I need to, the first thing I need to do once chopped up is to get the initial mass of the beetroots. Now if you've got digital scales, that's far, you can get a far more accurate reading. I've just got these scales, so that is reading 1/5 of 100 grams, which is
1/5 of 100 grams, that would be
20 grams, good. So what I've already done is I've written down my initial masses of my beetroots in a table like so. Okay, now the reason why we've got 4 pieces of beetroot is we're going to put these beetroots in 4 different conditions. Alright, so we're going to put 1 beetroot in just water, tap water. We're going to put 1 beetroot in a cup that has got 1 tablespoon of sugar added, so it's a sugar solution. 1 beetroot in a cup that's had 2 tablespoons of sugar added, so we've got a higher concentration sugar solution. And then we're going to boil. You are?
Isotonic.
Exactly, isotonic. And then we're going to boil one of the beetroots and see what happens with that one. Okay, so I did one of these earlier. Okay, so in this one here, in this cup, I'm going to label it because it's important we label stuff, isn't it?
Yeah.
I'm going to label this one W. That's going to be water. In this one, I've already put 2 tablespoons of sugar in there. In this one, I'm going to have my boiled beetroot, so I'm just going to label that one B. And then in this one will be my 1 tablespoon sugar solution. Okay, so it's just a way of you identifying which beetroot is which when you go back to it later. Now what I've put in there is I've put 100 centimetres cubed of water into each one. Now it's important we have the same volume of water, isn't it? Why? It's a control variable to make the test valid. So in this one I've added 100 centimetres cubed of water, and then I'm going to also add a tablespoon of sugar in there like that. Okay, give it a little stir in there and it will dissolve in there. You alright?
Is that a tablespoon measure that you
It was, yeah. It's nice, isn't it? It's good.
Very good.
So I've already done the other ones. I've already put my water in there, my 100 centimetres cubed of water, my water and 2 tablespoons of sugar, and again 100 centimetres cubed of water in there as well. Okay. So what you then need to do is take one of your pieces of beetroot and boil it. Now I've already done that earlier to save us time. Okay. And then you put them into your water like so. In they go. And what you want to do is you want to leave them for about an hour. You don't need to leave them for anything longer than that, because an hour is plenty long enough for you to get some good results. So I'm going to put these out the way. And then I'm going to get the ones that I did earlier. Ta-da! Look at that. Preparation. Okay. Now what we want to do now is we want to get the final mass, or the end mass. So after that hour's gone, you want to drain out the water. Excuse me. And then I've got a bit of kitchen roll on my scales to pat the beetroot dry. Why would I want to pat the beetroot dry?
You want to measure the excess water.
We don't want to measure the excess water. That would lead to errors, wouldn't it? Okay. So you want to then re-measure the mass of each of your beetroots and record it in a table like so. So what I've got, I don't know whether you can see this, but I've got the beetroot that was in just water went from 20 grams to 24 grams. The beetroot that was in 1 tablespoon of sugar solution went from 20 grams to 18 grams. 2 tablespoons of sugar went from 20 grams to 16 grams. And then the beetroot that was boiled didn't change mass at all. Okay, now there's two things I'd like you to do with your data once you've got it. The first is to work out a change in mass. So 20 to 24, 4 plus 4 minus 2, thank you. Minus 4 and 0. Then we can work out a percentage change in mass. Now we work out percentage change in mass because most of the time your beetroots won't be exactly the same starting mass. So by working out percentage change in mass, it's a better way of comparing the change in mass because it nullifies the effect of the beetroots not being the same mass at the start. Okay, so to work out percentage change in mass, you do the change, writing upside down, divided by the start mass, and then because it's a percentage, we want to times that by 100. So in this case here, it'd be 4 divided by 20 times 100.
4 divided by 20
times 100. It's a fifth, isn't it? 4. 4 is a fifth of 20, so it's 20%.
It's 20%.
20% change there. Yeah. A fifth. Yeah. 20% change. Okay. Now, the reason why the boiled beetroot had a 0% change in mass is because in order for osmosis to work, you need a semi-permeable membrane. And when I've boiled my beetroot, I've broken that semi-permeable membrane down, so it's no longer semi-permeable, it's completely permeable. So osmosis no longer works. Isn't that right?
That's right, you've broken down the cellular wall in the cell wall. Exactly.
So we're going to get water and sugar moving all over the place. So just as a little bit of science to finish off, because I've got some nice diagrams, look on the back. Here's my test tubes. So just to show you what's happening, is that this is simulating the beetroot that's in water, and the circles are water molecules, the squares are sugar molecules. So this is my beetroot here. Now you can see that in the water container, there's a high concentration of water molecules inside the test tube because it's water. So we call that a dilute solution because it's a high concentration of water. Now osmosis is the movement of water molecules from a dilute solution or a high water concentration to a low water concentration. So the water molecules are going to move that way, which means the beetroot is going to gain mass. Those water molecules are going to move through the semi-permeable membrane, which is why the beetroot in water went up, because it gained mass. In the sugar solution, okay, there's actually a higher concentration of water molecules inside the beetroot. So the more dilute region is inside the beetroot, so the water molecules move out of the beetroot, like so. Or the net movement of water molecules is out of the beetroot. So the beetroot loses mass. Alright? So what we'd like you to do, you've seen Mr. Golding's video, you've now seen this video which is an alternative. We'd like you to have a go at one or two of those videos at different ways of doing the practical, and take some pictures or take some videos of you doing it, of your results. We'll get them posted on Facebook. Let us know how you get on with the challenges. And you are?
Try a parsnip.
Oh, there you go, try a parsnip, he says. Alright?
Try a parsnip.
Or boiled egg.
Or a carrot.
Or carrot. I mean, the options are endless, really. Well, no, they're not endless. But there's loads of options. Bye for now, Year 9 and Year 10.
Bye.
Bye.